Good morning, my mathematicians. We are going to do day 9 notes today. Remember that you have a test on Tuesday because this is the last day of the notes for this unit. When I come in on Monday, we will go over homework 8 and homework 9, and then you'll be working on your review, which you have. So make sure that you've picked it up by the door there. Okay, so what we're doing today is given 3 points on a quadratic of a quadratic equation, you're going to come up with the quadratic equation. Okay, so I'm going to skip this top part this morning. I'm going to skip this. And we're going to have you come to this part because we'll go over that top part later when I can ask you questions and we can talk more face to face about that. We're going to go to solving using systems of equations. So this is what I'm basically telling you. That if I have a quadratic equation where I know 3 of the points on the equation, but I don't know the equation, I can find the equation. Okay, and this is going to bring you back to when you did systems of equations given 3, an x, a y, and z given 3 equations. So it's basically a repeat of that, but you're gonna see it a little bit different here. All right. So here is my equation: y equals ax squared plus bx plus c, or quadratic. Right, standard form. Now I'm gonna take that and I'm going to substitute all 3 of those points in here. And I remember 0, 4, 1, 9, and negative 3, 1 are points on some quadratic, one single quadratic. So what we're going to do is we're going to try and find that. So I'm going to take point 0, 4, start with that one. And I'm going to replace the y with 4, okay? And the x, all x's are going to become zeros because when x is 0, y is 4. And then I'm going to do it for 1, 9. And I'm going to do it for negative 3, 1. Each of the points. I'm going to take 1, 9 now. 9 equals 1 squared plus 1 c. And then I'm going to do negative 3, 1, that last point. Remember, you have to have parentheses. It's so important right there. Right here, it's so important because it becomes a square. Okay, now I'm going to simplify these. I'm going to rewrite them down here. So all the zeros, right, basically go away. And I got 4 equals c. They gave me one of the points, basically, which is nice. I'm going to rewrite this second one. Simplify it, basically. A plus b plus c. And then I'm going to rewrite the third one. I'm just going to simplify it some more. Now this is where the parentheses are important. See where it says a is multiplied by negative 3 squared. Negative 3 squared is positive 9. So it becomes a 9a minus 3b plus c. Okay? So these are now the 3 equations I'm going to use to find a, b, and c. Okay? So step 2, these are the steps that I wrote when we actually did the 3 systems. So you can go back to your notes from systems of equations, and you can look at that. It's the 3rd unit. It's unit 3. So you can look and see it was the last lesson we did. So it says for step 2, select 2 equations to eliminate one of the variables. Well, guess what? We have one of the variables already. We know that c is 4. So I'm just going to take 4 and put that in for equation 2 and 3 here. So I'm going to say 9 is equal to a plus b plus 4. And then I'm going to do it with this next, the bottom one. 1 equals 9a minus 3b plus 4. Okay? Excuse me, my nose is running. Right in the middle of the video. Good timing. Okay. And then I'm going to simplify further. I'm going to bring that 4 to the other side, right, for both of these. So this top equation is going to now become 5 equals A plus B. And the bottom one is going to become negative 3 equals 9A minus 3B. And then you're solved. You got this. You can just do a regular systems of equations, right? I would do an elimination method, probably. And multiply this one by 3. Let me change the color so you can see. Multiply by 3, and this would be 15 equals 3A plus 3B. And this is negative 3 equals 9A minus 3B. Combine, the B's cancel out. I've got a 12, I have a 12A, and I know A is 1. Now I have C is 4, A is 1. Plug them in, back in here to find B. Alright, that's all we got left to do. And I would probably pick that 5 equals A plus B. 1 plus D, and B is equal to 4. Okay, so now I've got, let me say it again, A is 1, B is 4, C is 4. I've got a quadratic. I've got the quadratic y equals x squared plus 4x plus 4. That quadratic, if I put it into my y1 in my calculator and go to my table, it will have the points 0, 4, 1, 9, and negative 3, 1. That is the quadratic from those 3 points. Pretty cool, huh? Okay. So that is what you're going to, if I was there right now, you would stop on page 2 and you would practice that. So I expect to see that on Monday. I will tell you what the answers are so you can check it. When I did it, I got A is negative 2, B is 3, and C is negative 1. So follow the steps from the front page, plug them into the y equals ax squared plus bx plus c, come up with the 3 separate equations, and solve for a, b, and c. Okay? Now, we're going to jump into using second differences. This is one of my favorites to see. I love seeing this pattern. Okay, so take a minute, and you're going to read this number 3 here. Okay? So take a minute and read that. Okay. Exactly what we wanted to do was to drop some watermelons, right? And that's what you guys do in your free time, I'm sure. So, this problem, what we're trying to determine right here, is we're first going to look to see whether it was linear or not. So, like, on a Regents exam, excuse me, they would give you a table like this, and they would say something like, you know, is this a linear or non-linear? And you would look to see that, you know, based on the numbers, this is not a constant rate of change, right? What you're really doing is you're going, okay, I'm going to look at what they call the first difference, okay? And I'm going to just take the difference between 284 and 300. And when I subtract 284 minus 300, I notice there's a difference of negative 16. And you're going to do it again, 236 minus 284. So you're just looking at the differences between one height to the next for each time, at each time. And then I'm going to do 156 minus 236, and I'm going to see negative 80. And then I'm going to do one more, 44 minus 156, and I'm going to see 112. Okay? Now, that's called what we often say is the first difference. We've never said that, but that's what you do when you're trying to find whether something is a linear or not. You normally take the difference in the y's and the difference in the x's. You can see the difference in the x's is going one at a time, so I didn't do that. And by the way, when you go to do these, first difference, second difference, you have to remember that you are going to want it so that like it's 0, 1, 2, 3, 4 for the x's. To keep it simple, you're going to want to do it one step at a time. You're not going to go from 0 to 5 then to 20 for the time. Okay, so it's going to be a step like in which basically the table is going up one at a time for the x's. Then we're going to do something called the second difference, which is new to you. And what the second difference is it is checking again to see what is going on between these numbers, between negative 16, negative 48, negative 80, and negative 112. And you're going to do it just like you did before. You're going to take negative 48 and you're going to minus 16 from it. Let me say that. Let me write that so that you can see it. Negative 48 minus negative 16. And when you do that, you get negative 32. And you're going to do it again. You're going to do negative 80 minus negative 48. And when you do that, you're going to get negative 32. And then you're going to do it one more time. Negative 112 minus negative 80. Guess what you get? Yes, folks, we get it. Negative 32. What? What's going on there? Negative 32 3 times. That means this is a quadratic. It's amazing. I love it. I love that. I love seeing that new test that you guys now know. So how do you test to see if a table is indeed a quadratic? You do the first difference and then the second difference. And as long as the second difference, all these numbers are exactly the same, when you do the second difference, you know it's a quadratic. It will work every single time. Every time. Okay? So let's write it. Second difference will always be equal if the table represents a quadratic. Okay, so we determined that that's a quadratic. Do you need all 5 points then to write the equation? No. Are there any points that are particularly useful? Yes. Doesn't matter which one. Yes. Okay, well, let me explain. I'm going to go up to that table, and I see 1, 2, 3, 4, 5 points, right? 0, 1, 2, 3, and 4. I'm going to tell you that you've got to pick 3 points, right? Pick 3 points, and you have to do what we did on the front. You have to plug them in to find which ones you're going to do for the A and the B and the C. Okay. Now I would purposely pick 0, 300 because when I plug that in, that's going to give me my C value, just like it did on the front. Let me show you what I mean. So here is my quadratic, right? My standard form of a quadratic. I'm going to stick in that 0, 300. So the y becomes 300. And all the x's become 0. Right? And look at that. They all cancel out because anything times 0 is just 0. And I get 300 equals C, just like I have in the front. So oftentimes, you're gonna get that a lot. I know on example 2 above, when you practiced it, you didn't, but That's typically what I'm going to give you. In fact, I will give you one like that for the test too, just to make it simple. Just because we have bigger things that we need to test you on than just this one. Okay. So the other point, let's see, let's pick 1, 2, and 284 from that table. And you're just going to do what we've been doing. Like I said, you're going to plug it in. You're going to put 284 as the y. And 1 is your x. And you're just going to rewrite this. A plus b plus c. That's an easy one too. And then I would just pick the next smallest for the when I say smallest, I mean for the x values. Put this in here. And I would say 236 equals 4a plus 2b plus c. And there's your 3 equations in which you are going to, again, do a systems of equations, right? Put the c in for each of these, probably what I would do, and then have a systems, and you're just going to end up with the a and the b that you need to find, right? And then you use your calculator to check. And when you're done, I will tell you this. Your a is going to be negative 16. Your b is going to be 0. And your c is 300. So then I would say, okay, give me the quadratic, right? Given those 3 points, give me the quadratic. The quadratic is negative 16x squared plus 300. And that right there represents up here, can't move it, represents this whole thing. Okay, that is the quadratic that you got just from those points alone. And you knew that it was a quadratic because you did the common difference. Okay, folks, that's it for today. Go through, make sure that you have filled in the rest of your notes here. Do some homework. You've got the rest of the period to work on your homework and practice these because they need a little practice. And I will see you Monday. Have a good weekend. Oh, and I am there later in the day if you need me, okay? So if you need anything, I'll be there probably sometime after 3rd period, okay? All right. Bye-bye.